Okay, so let us now continue with 4.2 wave. Now we will try to understand certain terminologies here. One is the concept of what exactly is phase. In any vibration or oscillation, object that vibrates is at different position. The position is identified in terms of phase. It is represented as angle. Let us understand now. So let us recall a bit from the simple harmonic motion we saw. If you can recall the spring, and then we saw three different positions here. We saw the displacement 0, displacement max, and then we again saw displacement max. And if, let us say, the object starts oscillating from this point, and then let us say goes up maximum, then comes back to this point again, equilibrium, and then comes down and then goes back here. We all know that this is one oscillation, right? This is one oscillation. Now if I have to show that in terms of angle or as a waveform with a crest and a trough, I would show it like this, right? So this is my crest, if you remember, this is my trough, and I'm going to take this one as 0 degree, okay, and I will take this as my 90 degree or as a pi by 2 radian. I will take this as my 180 or 2 pi. I will take this as 270 or 3 pi by 2, and then I will take this as my 360 or 2 pi radian. Alright, now I am coming back to this wave. So this is my 0, this is my pi by 2, this is my pi, this is my, here it is 3 pi by 2, and then I have my 2 pi. Okay, so this can now be shown in a circular structure. See, so this is how your oscillation can be represented: 0 degree, pi by 2, pi, 3 pi by 2, and then back to again 2 pi, one oscillation here. Okay, this positions are called phase. Now come to something called, let us discuss path difference. We discussed a term where we said wavelength, and we also understood that it is the path covered by a traveling wave in one oscillation. Okay, now if I have some waves, for example, say I have here two waves, let's say one which starts like this, one which like this. Now I have to discuss here between both what is the phase difference. Okay, phase difference. So this is A, this is B. Look at this, this is 0, this is pi by 2, and this is pi, we all know that, and this one is starting exactly from this point. See, so this is pi, and then comes your 3 pi by 2, and then you get your 2 pi. So we say usually that the phase difference the phase difference is pi, 180 degree, 180 degree or pi. Okay, exactly same way, if I look at both A and B, from A and B, see this is one full lambda, right? We all know that this is full lambda complete. Then how much is this? This one is starting from here, which means he's behind him by lambda by 2. So we say that path difference between A and B is lambda by 2. Okay, so this was just for your basic information. We might need this at a later stage. Now coming back to a concept called wave front and ray. So wave front and ray. So what are these now? How do we understand them and how do we define them? So let us understand first wave front. Say this is water, right? This is water here, and then I have dropped a stone here. We all know what will happen. We are going to get ripples, like last time I discussed with you. Okay, and then I will get ripples, more ripples here. Now look at this point, this point, this point. They are all in the same phase. They are all going together, maybe up. Then look at this point, and this point. They are all in the same phase. See? So when I join these same phase particles, then I get circular structures, right? So the wave travels in the circular structure. This particular structure that you are seeing, circular, is called your wave front. Okay? So waves travel as crest and trough, and I am talking of transversal. Okay, because when you throw the stone in the water molecules vibrate, up and down, and then the wave travels this way. So there is a perpendicular direction. So this is the transversal wave, the wave that is created in the water by the stone. All right, now so these are all collection of those points which are in the same phase. So these are basically nothing but collection of particles in same phase. Okay, now there are different structures of phase wave fronts. So if you have, say for example, a tube light. Okay, now let's say one example, a tube light. A tube light is cylindrical structure, so its light will go everywhere this way, and then your 3 dimensions. So we can draw a circle, I can again draw another circle, I can again draw another circle, and then I can join. See, so the wave front that a cylinder will have will be cylindrical wave front. Okay, so this is a cylindrical wave front. Then what about your light from the sun, which is very far away, and we consider the lights to be coming parallel? So if the lights come parallel to you, from infinity, okay, these are coming from far, very far, infinity, then how do we get the wave front? The wave fronts are something like this. See, something like this. Okay, plane wave fronts. You get plane wave front. All right, and if something is like, say, a star, another example is like a star. Now star will have spherical wave front. Spherical wave front. So these wave fronts are very important, because whenever we are going to talk or discuss about how the wave behaves, now we are going to discuss in terms of the wave fronts. So all the experiments which are done basically from the wave fronts. Okay, and let us now just understand what exactly is a ray then. Okay, so a ray is nothing but the direction of a wave front. So if you have a wave front which is circular, as we saw, and then you have the source here, then your wave front are going this direction, so you draw the arrows, you draw the arrows, and these arrows represent your ray of that. So these are your ray. That's why we say, for example, a ray of light. Okay, there is a wavefront, but then we say it's a ray of light. That means we are talking of the direction of wavefront. Okay, now in the next topic, when we discuss, we are going to talk about the reflection and diffraction aspect of a wavefront, because wavefronts can undergo reflection and refraction. Okay, that we'll discuss in 4.3 and 4.4. Okay, thank you.